7.1 Solving System of Equations. These are the objectives. You can pause to read. I'm going to the next slide. So this number 1 says solve the system by the method of substitution. Check your solution graphically. So here's number 1. Your first equation, you should recognize that it's a line. The second one generates a circle. So solve the first one for y. Substitute y into the second equation. So you're going to plug it in here. You did this in algebra 2. So then you get the following. You have to expand this binomial. Once you raise it to the second power, you get the following. You add it with the x squared. Simplify the 25s. And then at this point you have a quadratic equals 0. Factor the common factor between the two terms. You did this in algebra 1 and also algebra 2. At this point, apply the zero product property, and you get x equals 0 and x equals 4. From here, once you have your x values, you have to go back and substitute back into your equations, mainly this one. This one is easier to work with, and find your y value. Substitute x equals 0 first. In here, you get -5. Substitute x equals 4, you get 3. So this is your answer. These two intersect at 2 points, 0, -5, and 4, 3. Now let's check this using the graphing utility. So this is the window that you want to work with. This is -8. This is your first function. To graph the second function, this circle, you have to actually input two different functions. I can clarify this in class, but this is the square root of 25 minus x squared, and the second one is negative square root of 25 minus x squared. Once you do this, you get the following graph, and notice that this is where they intersect, and they match what we have here as our answer. Let's go to number 2. Same directions, different problem. So you're looking at solve this for y, and you get the following. You're going to substitute this y value in here. You get the following. At this point, you're going to simplify these two terms. You get x cubed minus 4x equals 0. Factor this binomial. Pull out an x. At this point, continue to factor this binomial. You get the following. This is going to generate 3 answers. X equals 0, -2, and +2. And again, you go back and substitute it into this one. You can also substitute it into this one. I'm sorry, this one. But it'll be a little bit more challenging. So x equals 0. And here I get y equals 0. X equals -2. I substitute and I get y equals +2. X equals +2 generates y equals -2. So this is the answer. This is where these two, this line and this curve intersect. This is the window, and again this is -5 that you want to use. This is what you want to punch in. Solve this one for y, and you get the following here. And once you as the calculator to graph this is what you get. And notice that your points of intersection match what we have here. Number 3. Same directions. So we're going to do this algebraically. You're going to set both of them equal to each other. Move everything to one side. You want to move everything to the left side because you want the leading coefficient to be positive. Because you want to factor this trinomial, pull out an x, you get the following. At this point, work with this trinomial, Apply the factoring techniques you learned in Algebra 1 and also Algebra 2. You get the following. This generates three x values, 0, 1, and 2. And then at this point, you're going to substitute x equals 0 into the second equation. And you get y equals 4, x equals 1 generates y equals 2, x equals 2 generates x equals 0. And here's the answer. Now let's do this graphically. This is the window that you want to work with. -3. This is what you punch in. This is, excuse me here, this is x cubed here. -3x squared plus 4, which is this one, the first equation. You graph this, and you get the following. And again, notice that these points, the points of intersection, here, here, and here, match what we have as our answer. Let's go to number 4. So directions, we're gonna substitute, solve this one for, excuse me, this, let me get a pen, solve this for y, you get the following, and then you're gonna substitute this y in here. So you get the following equation, move everything to one side, simplify, you get the following trinomial. Notice that there's a GCF of 2, so divide everything by 2, and you get the following. Now factor this, you get this, x minus 4 times x plus 2, apply the zero product property. This generates x equals 4 and -2. Substitute, again work with this one. When x equals 4, you get y equals 10. When x equals -2, you get y is equal to -2. So this is the answer. The graph, the window that you want to use is right here. Then at this point, plug in your two functions. This is negative. Oh, actually, excuse me, this is positive 2x squared. Minus 2x minus 14, solve for y here. And again, solve for y, which we did over here. That's why we have this as our second equation. You graph these, and you get the following. And notice that these points of intersection match our answer. Here's 5. So what we want to do is solve the second equation for y. You're going to substitute into the first equation. You get the following expression. Move everything to one side. You have the following trinomial. At this point, you're going to try to factor this. You can also apply the quadratic formula. And you're going to notice that you're not going to be able to factor it, or you're going to get an imaginary answer. That's why this is not factorable. Or if you remember from Algebra 1, this is what we call the discriminant. And notice that what's inside the radical, you have less than 0. So that's why it is going to generate a solution that is not real. So at this point, you say that there's no real solution, and it'll make a little more sense once you graph it. So here's a window. Here are your two functions that you want to graph. And notice what happens with the graphs. Since there's no real solution, it implies that they do not intersect. We're done with 5. Let's move on to number 6. Same directions, substitute, set them both equal to each other. You have the following equation, move everything to one side. You can move this -x to this side, or add x to both sides. You get the following. You have this trinomial, common factor of x. You have this. At this point, you're going to notice again that this is not factorable. The discriminant is 0. You apply the quadratic formula, you're going to get an imaginary number. So that's why you only have x equals 0. And again, the discriminant is less than 0. So then at this point you find the y value, you plug it in here, and you get 0, 0. If you want to graph this, this is the window, and again this is -5. This is what you punch in. This is -x. And this is what you get as your graph. And notice that the only point of intersection is at the origin. We're done with 6. Let's move on to number 7. This is a word problem. It says a small fast food restaurant invests $5,000 to produce a new food item that will sell for $3.49. Each item can be produced for $2.16. So part A says write the cost and revenue functions for X items produced and sold. So here's your first equation for the cost: 5,000 plus $2.16 times X, because that's how much it costs to produce an item, and the initial investment of $5,000. The revenue is just how much this item is going to be sold for, which is $3.49, times X, which is the number of items. So part B says graph the first part to approximate the number of items that must be sold to break even and verify the result algebraically. I'm going to switch the order. First we'll do this algebraically. So in order to find out where we break even, we have to set the cost and revenue equal to each other. That's why we have this equation. Solve for X. The algebra is really easy. You have a calculator as well. Divide both sides by 1.33, and you get the following. So to answer the problem, you need to sell 3,759 units to break even. Let's do it graphically now. So this is the window that you want to use. These are your two functions. And then this is what you get for your graph. And then in class, I can show you how you can get this X value for the intersection point. Remind me and I'll show you exactly how we can do this. You can approximate, but if you want to be exact, you want to use a specific feature in the graphing calculator. So we're done with number 7. Let's jump to the last one, which is number 8. Here's number 8. I know some of you are going to enjoy this last problem. Here we go. This is what it says. It says you are offered 2 jobs selling chicharrones. One company offers an annual salary of $25,000 plus a year-end bonus of 1% of your total sales. The other company offers an annual salary of $20,000 plus a year-end bonus of 2% of your total sales. How much would you have to sell in a year to make the second offer the better choice? So you're going to set the 2 offers equal to each other. And here's your first offer and the second offer. Once you have this is pretty straightforward. Setting up the problem is the challenging part. But and again, this is not too bad as well. And then solve for X. Take away 20,000 from both sides. Take away 0.01x from both sides, and you end up with this. At this point, divide both sides by this value here in front of the X, and you end up with the following X value. So to answer the question that you have here, for the second offer to be a better choice, you would have to sell more than $500,000 per year. A lot of money. But this is the answer to number 8, and this is the end of the video. And I want to say hello to all the chicharroneros. Goodbye.